Hello and welcome to my Math Companion. In this series of videos, we will be looking at how to solve quadratic equations by completing the square. In this video, we will be looking at a simple example. So let's begin. We must solve x squared plus 8x plus 12 is equal to 0 by completing the square. So in any quadratic equations problem, you must first write your equation in the form of ax squared plus bx plus c is equal to 0. We see that our equation is already written in that form, where a is equal to 1, b is equal to 8, and c is equal to 12. So the next step is to take this constant term of 12 to the other side of the equation. That is, we subtract 12 on both sides. This is an extremely important step, and you will see why in the next couple of slides. What we must now do is we must get on the left hand side a perfect square. We must get the perfect square of a binomial term of the form of x plus d the whole square. So this d is a constant term that we must find. And now we see that the binomial expansion of x plus d whole square is x squared plus 2dx plus d square. And since we want on the left hand side x plus d whole square, this means that the binomial expansion of x plus d whole square must be equal to what we have on the left hand side of the equation, which means that the x square terms must be equal, the x terms must be equal, and using the value of d that we find from the x term, we can figure out this constant d, and therefore we can figure out the value of d square. So first we see that the coefficient of x square in the binomial expansion of x plus d whole square is 1, which means that we need the coefficient of rx square in our equation to also be 1, which we see is already 1. However, in many problems that you get, the coefficient of x square will not be 1, and in that case you will have to divide the entire equation by the coefficient of x square. Now note that dividing by the entire equation by something means dividing on both sides of the equation. Those two things mean the same thing. So in our case, the equation will remain the same, since if we divide by 1 on both sides of the equation, it will remain the same. So now, since we have equated our x terms, we must now equate our, since we have equated our x square terms, we must now equate our x terms, which means that we must have 2dx be equal to this 8x. Since 2dx is the only x term in this entire binomial expansion, and on our left hand side 8x is the only x term. This means that we must have 2dx equal to 8x, and now you will see that we have two variables and one equation, and you may wonder how we're going to solve this equation. You must note that both the sides of the equation have x, which means that we can simply cancel them out and get a single variable equation with 8 equal to 2 times of d. So now this is quite solvable, since we now have to isolate d, and we will do that by just dividing by 2 on both sides and getting d to be equal to 4. So now we will input this value of d back into our binomial of x plus d whole square, and we will get x plus 4 whole square is equal to x square plus 2 into 4 into x plus 4 square, which is equal to x square plus 8x plus 16. And now notice that this x square plus 8x is recurring, and this 16 has been an addition. It's an additional term. So now, since we know that x square plus 8x plus 16 is a perfect square, and that's exactly what we want on our left hand side, we will add 16 to the left hand side. But when you add something to the left hand side, you must also do the same thing to the right hand side. So we must add 16 to both sides of the equation. So on the left hand side, we will get x squared plus 8x plus 16, which is what we want, since that's our perfect square. And on the right hand side, we will get negative 12 plus 16. And now you might see the significance of why we moved this 12 to the right hand side. If we had not moved this 12 to the right hand side of the equation, we would have added 16 to both sides, and on the left hand side, you would have gotten x square plus 8x plus 12 plus 16, which would give you x square plus 8x plus 28. And on the right hand side, you would have had only 16. And then subtracting 16 from both sides, you would have come back to your original equation of x square plus 8x plus 12, which would not get you anywhere. So in order to avoid such mistakes from happening, we just take this constant term to the right hand side. So now we know that the left hand side is a perfect square of x plus 4 whole square, and negative 12 plus 16 is just 4. So now what we can do is we need to solve for x, which means we need to isolate x. And we see that x plus 4, the whole binomial of x plus 4 is being squared, and the opposite of squaring is taking the square root. So we will take the square root on both sides of the equation to get x plus 4 is equal to square root of 4. And this means that x plus 4 is equal to positive or negative 2. Do not forget this positive or negative sign, since both positive and negative 2 whole square gives us 4, which means that the square root of 4 can be either positive or negative 2. So now we must solve for x. And we see that x plus 4 is on the same side of the equation, which means we must take this 4 to the other side of the equation. So first we will take positive 2 and evaluate the value of x. So this means that we have x plus 4 is equal to 2, and subtracting 4 on both sides of the equation, we will get x is equal to 2 minus 4, which is negative 2. So this is our first value of x. Next, we will take negative 2 on the right hand side and do the same procedure. We will subtract 4 from both sides, and this will give us x is equal to negative 6, which is our second value. So this means that x is equal to negative 2 or negative 6. And these are our two values for the equation. So this is how you solve a quadratic equation by completing the square. In the next video, I will be looking at a more complex example. So I will see you in that video.